Hello everyone, we are back and we are going to be going over an example of using Spark in the cloud, in Google Cloud, and also using lambda functions. So first things first, we come back to our dataproc interface where we should have a cluster running, and this is mine PySpark project. So go ahead and click on the cluster, and then remember we go to configuration, scroll down a little bit, and we'll come up to our link for our Google bucket, which we're going to use here in a second. And then under web interfaces, if we scroll down a little bit, we'll see Jupyter Lab. So we click on that. I'm doing control click here to open up new tabs. And that'll take us to our Jupyter Hub interface. So the first thing is you'll probably have no Jupyter notebooks here or anything. So we want to actually get some in there. So from some of the demo files in the week 7 demo files here, at the bottom of week 7, there's all these additional files. And the name of this Lambda Functions demo is a little bit different, but if you have those files on your file browser here, and you have Jupyter Hub open, we can just drag and drop those things. So the first one to try out is just test our Spark installation. So drag that into this file browser here, double click it, it opens up. If it doesn't already auto detect the kernel, sometimes it'll ask you to select a kernel, and we will be using the PySpark kernel here. And the reason for that is because when we use PySpark kernels, it automatically loads PySpark for us and creates these variables sc for Spark context and Spark. So we can just run this first cell, and it should run, and should be getting the existing Spark context, and then it's approximating Py with just some math here. So if that works, no errors, then your Spark installation is working. So you can use this to test other methods. If you want to use a local installation or AWS or something else, you should be able to use this notebook to test the functionality. So here we're going to be going over this Spark and Lambda functions file here. So it's a demo going over how to load data into Spark and how to use Lambda functions with Spark, because that's an integral part of the project. So the first thing with these PySpark notebooks, we can actually just type Spark, and it gives us our Spark session right there. So it connects to Spark, and then when we do that, we also have our sc, which is our Spark context available, so we can use those variables to load data and use Spark. So in this demo, and also in the other demo, the word count demo, we start off by downloading the data, and an exclamation mark in a Jupyter Notebook cell means we're running an operating system level command. So wget is a Linux command to download something, and we're downloading this shakespeare.txt file. So we do that, it downloads it. When we do ls to print out the files, we can see we've got Shakespeare. I've downloaded it a few times here, so it keeps on adding numbers to the end. And when we're using Spark, we have to load from some sort of big data store, because Spark is really made for big data. There's not a whole lot of point to using Spark if you're not using big data. So we actually are going to copy this file into HDFS on our cluster. So remember, HDFS is distributed across all the machines on the cluster. So we run this command, exclamation mark again, to run an operating system level command. And then I've already got it in the file system. So with the ls command from HDFS, we should be able to see it there. So it looks good. And one caveat, when we load it, remember we give this HDFS:// kind of like a web address, and then we give it the file path to the file. So you pretty much always have this triple slash here because of the 2 slashes from the syntax, and then the 1 slash for the root or home directory of the Linux file system, or the HDFS file system. So we load this text file with this spark context.txt file function. That's one way to load text, and that loads it as this RDD, the resilient distributed data set, or whatever the RDD stands for. Can't remember off the top of my head. And one thing that's important to remember is that this variable is not actually going to be loaded until we call some command like take or collect or save. And at that point, it'll actually run all the code up to this point. And remember, that's because Spark has lazy execution, which means that it doesn't run anything until it needs to. So just in order to make sure that it's actually loading the data, you need to run this take. So for example, if I add an extra s in there, I give it a file name that doesn't exist, it still prints out the type of the variable. It doesn't give any errors when we run this line. But then when we try to look at the data, basically this error is going to say file does not exist somewhere. Yeah, here we go. Path does not exist. So be careful of that. All right, so reloading the data, looking at it. Another way to load the data, which loads it into a data frame, and this has a lot of other options for reading different types of files like JSON and CSV and other things, is spark.read. And so we use the same HDFS file path and read it into there. And again, use text.take to make sure that we've actually got it there. And you can see this output of this is a little different than it was for the Spark context RDD. So it's got these columns because it's a data frame, so it has a little bit of different functionality, but we can just convert our data frames to an RDD just like that. And then it works the same. And there's also this .show command where you can kind of format columns a little more nicely, kind of like pandas. So one other thing is you might want to load the data from a Google bucket, which might be easier because then we can just drag and drop our data into a Google bucket. So let's get this Shakespeare from Peter Norvig's site. So I'm just going to download it here. Let me just save it to desktop. And so we can grab that and just drag and drop that file right into our bucket. So I think because I've got my, things were zoomed in, so it's kind of hard to see there. Get this in a spot where I can drag and drop. So we can just drag that right in there, uploads it to our bucket, and we can get the name of our bucket from multiple places. I'll just copy it from right here. This line right here is always going to show you your path. So if we go in a folder, we can see that it's got kind of our file path here. So I've got the bucket name, and let's change the loading of the data so that we use Google storage instead. So instead of HDFS, it goes GS for Google storage, and then we give it our bucket name and then path to the file. And I don't think we need the triple quotes with Google storage. I think double quotes works fine. I think triple quotes, okay. So yeah, so that's kind of a quirk. You have to use double slash with Google storage and triple slash with HDFS. So one of these things. Anyway, so we've got the data loaded from Google storage there, and it looks the same, so that's good. All right, so now on to actually doing some processing of the data. So let's first start with just taking a sample of the first few lines of the data. We're creating a new variable. So it's a list of these strings. And we're going to get each one of these words in this multi-line string here, or it's not a multi-line string, but we're going to get each one of these words in this list of strings. And so one way to do that, create an empty list, go through each line or each element of this list one by one, and then we split that line, and this dot split is a built-in Python function. We can use it on strings. So if we have this first line of our text dot split, we can see it's splitting on white space. So it splits on all different white space, including new lines and spaces and tabs and everything. So so when we call this function, and let's just abbreviate this to the first few words, we go through each element in the list, split it, and then add it to this list, and then just look at the first few elements. So we can see we've got individual words here in our list. So instead of doing that, we can also use a function to split the words like this. So it's the same idea, except now we're creating a function. And so with Python functions, we have this def for define keyword. Then we have the name of the function. We have parentheses with any arguments in there, a colon, and then a new line with a tab indentation, or which usually gets converted into 4 spaces in a lot of development environments like Jupyter. So then we do whatever code we want to do in here, and then the last thing we usually do is return some variable or variables. And so this return is what we get back from our function. These arguments are what we put into the function. So we can do the same thing, create an empty list, go through each element of that list we have up there, and then use our split words function on each element of the list to get a split line, and then we will get the same result. Oops. So we can see we get the same thing, and we're doing it with a function. So that's kind of a quick intro to functions in Python. There's a link at the bottom of this notebook that also goes to a data camp tutorial on functions, which you can use as more of a reference. So next, so instead of looping through this list, we could also use a built-in Python function called map, which map takes a function and then some iterable like a list, and it applies that function to each element of that list. And so if we call that map function, then we can see it actually applies that function to each element of the list. And this is a minor difference between Python 2 and 3, since we're running in Python 2, I think, here. Let's see, I think this, yeah, we're running Python 2. So in Python 2, this map function directly returns a list. In Python 3, it actually returns an iterable, so we wrap it with this list keyword to convert it back to a list, just in case we're in Python 3. But anyway, that does the same thing as our loop up here. The only difference being we were using this extend function here, which adds on a list to the end of a list. This one is more like doing append rather than extend. So that's why our result looks a little different. But with map, it's part of MapReduce and it's part of Spark, so we use that instead. Okay, so that is using functions and using them in a map way. The next part is using lambda functions. So lambda functions are these so-called anonymous functions, which we just create on the fly, and they don't have a name. And so the syntax for this in Python is the keyword lambda, so we can see it's getting highlighted in green. We give it any input arguments, and then colon, and then whatever the function does. And so then it just returns whatever is in this area of the function. So for quick little functions where you want to do one or two things and not a whole lot, you can use lambda functions. So if we would just want to split up our line, this is a perfect case for a lambda function. So we can see instead of using our split words function, we can just use this lambda function, and we get the same result. So that's all there is to lambda functions. For some reason, they just take a little bit to understand, but once you see them a little more, you'll start to get more comfortable with them. So, instead of using this line as a variable, we could use any name for the input variable. Very often, people use just a generic x like this. So, and now instead of using the Python map function, we're actually using let's use our text dataframe.rdd. And I don't know why I didn't like that. Let's see. So yeah, so when we load this text file, it gets loaded as an RDD, and it's a little different than this data frame. So I think in order to use the data frame here, we'd have to change the syntax a little bit. So anyway, we can use the map function on RDDs to call a lambda function and do the same thing as the map function in Python. All right, and I think, just real quick, since it'd be helpful probably, if we do want to use the data frame, I think we'd want to use something like, we want to get that column of the data frame. Something like that. So yeah. So if you go back and look at how it loaded the data frame, we can see that this first column doesn't have a name because it's not like a CSV. Actually, it's a text file. So it just gave it this dummy name underscores C0 for column 0. So in order to access that column, we just take our inputs row of the data frame and then we index to that column. So same idea. And those two results should be identical. The only difference is it looks like the data frame skipped the empty blank lines. Okay, so on to a few more Spark functions that are useful. There's flat map, and we've got flat map, and then group by key and reduce by key. So we're going to look at those three functions here. So let's start with flat map. Flat map's a nice function. Again, we're giving it a lambda function here of splitting all the words. So notice when we did this up here, it gave us a list of lists. So each element in the list is a list, and that can be okay depending on what we want to do, but in our case, we don't want that because we're trying to count the words. So we use flat map to actually just create a one-dimensional list, and that'll help us get to our next step. And even instead of using this lambda function, we can just give it a function name here to use that function in our flat map function. So these get us to the same end result. And next, for word counting, we are going to just use a map function again. So we've got this word variable, which is this list of words here. So we're taking a lambda function, our input word, and then we're outputting a tuple in Python, which is kind of like a list, but you can't change the elements in there or add to it or anything. So this tuple will have our word and then the number 1. And this is very similar to the generic MapReduce word count, how it works. So now we've got our list of words and the number 1. And now we want to just count up the number of times these words appear. So we take all of these pairs of words where the same word is this first element in the tuple, and then just add up the number 1. And so that's what we're doing here. We're using this reduce by key and this add function from the operator library in Python. And that add function is just basically doing this lambda function, which, let me get this a little more nicely formatted so it's easier to see. So lambda x and y are our inputs, and then we just add those two and return that sum. And reduce by key is going to basically take all the same keys, which are these first element of these tuples, and just keep applying this function to it until there's only one element where it has that key. And so this effectively kind of groups up all the same words and adds up all the ones. So once we do that, we can see that we get our word counts of things in the text. And another way would be, of course, to use that lambda function that is the equivalent of the operator .add function, so we get the same result. So another way to do this would be to actually group by our key. So group by key is very similar to reduce by key, but it gives us the common first elements of the tuple and then basically this iterable of all those second values of the tuples. So what that looks like, and remember collect is going to show all the entire output of a Spark operation, so let's just take the top few instead. So we've got our iterable. So to actually convert this iterable to a list where we can actually see the data, we need to wrap it in the keyword list. So we can do the same group by key function and then take that and do a map function with a lambda function. And our lambda function is taking this input, which are these tuples, and then it's taking the first element of the tuple, and then it's converting the second element of the tuple to a list. And so that ends up looking like this, where we've got the word and then a list of the number ones. And then to get to our word count, we can just wrap this list of ones in a sum, and when we run that, then we get our same word count results we got before. So that's about it. So we've kind of covered everything from starting Spark in our cluster all the way up to, so then we loaded the data, loaded it into either HDFS or from HDFS, or we loaded it from Google Storage. And then we went through functions, lambda functions, and then mapping with functions and using some of these Spark functions to do a word count analysis. So this is very similar to the Spark word count file. So you can also go through the Spark word count file for another example of this in a little different way and with some more explanation in there. You might also visit the links here for the Spark documentation on some of these functions, like the reduce by key function, to help understand it a little more. And if you're still feeling confused by these functions and lambda functions, there's this DataCamp tutorial here which you can go through, and it covers functions and lambda functions. So if you're still feeling shaky on that, check that out. All right, well, I hope this is helpful for the project, and we'll talk to you next time.